In this video, we are going to talk about two-sample t-test assuming equal variances. This test is a statistical test designed to measure the significance of the difference in means of two variables. Comparisons between two samples are frequently undertaken where the objective is to assess whether the simple means are different or have changed in some ways. So in this example, we are going to look at two different methods of titration. One is manual titration, and the second method is automated titration. These are all the data points for the two different titration methods. Now, the hypotheses for this test are as follows. The alternative hypothesis is that the null hypothesis is that there is no difference in the mean values of the two titration methods. It's basically what these symbols are saying. The alternative hypothesis is that the difference in the mean values is equal to some value. It's not zero. There is a difference in the mean values of the two different titration methods. And our confidence level interval is at 90% with the alpha value of 10%. Now our objective is one tail, meaning that we are trying to assess if there is an improvement, if the automated titration method is yielding better results compared to the manual titration method. So basically we are specifying in this test that we are trying to see if there is an improvement. So if our objective is one t-tail. Everything here is already done, set up in a manual format. All the calculations are manually done with equations and functions here. And we have the results on this side. Now, based on our data here, the result is rejecting the null hypothesis. It is saying that there is a difference. So the null hypothesis that there is no difference between the means has been rejected. Now, how confident are we that this result is correct? We look at the p-value of the one tail. Because our objective is one tail, we look at the p-value of the one tail. The value here is 0.05 is less than our alpha value here of 0.1. Therefore, we reject the null hypothesis and we accept the alternative hypothesis that there is a difference. Now, the chances of us getting this result wrong is around 5%, which is basically this value. So we are around 5%. The probability of this result being wrong or this interpretation being wrong is 5%. So we have around 95% probability that this response is correct and that the difference in means is not zero and is statistically significant. So what is the difference in means? So these are the mean values of the two titration methods, and the difference is up here. It's around 0.37%. So we are concluding this test that this 0.37% is significant and did not rise by an error or by chance, but it is real and it's significant. Now our confidence limit is at 90%. We are 90% confident that the difference in means is 0.037%. Now, the true value of the mean lies between this interval, the confidence limit of plus or minus 0.38%. So that means the true value of the difference in means is between 0.076% and negative 0.007%. Now in this test, to conclude, based on our objective as one t-tail test, we are rejecting the null hypothesis with 90% confidence that the difference is real and it's significant, and that the automatic or automated titration is yielding higher or better results compared to the manual titration method. Now, if our objective were to be two-tailed, then the hypothesis is set up with conditional formatting that it will look at the p-value of the two-tail. Now, the difference between one tail and two tail as an objective is one tail you are specifying the direction. You are basically looking for an improvement. If your objective is just to see whether there's a difference between the means of the two variables, two sets of data, either the difference is a positive value or a negative value, we didn't specify the direction, then you will take your objective as two-tailed. If you are only looking for one-sided t-tail or one directional t-tail, like if you are looking for an improvement in this case, then it is a one-tailed t-test. Okay, all of this is manually set up in a template. So you just enter the data here and it will give you the result. Now Excel has a tool that can do the same thing. You can go up to the data tab on the ribbon, go to data analysis, click on t-test sample assuming equal variance, and you select your data here. So variable range 1 is this column here, or array. Variable range 2 is this set of array, and the alpha value is here. Its alpha value is around 10% to 0.1. So it's 0.1. And the output range, we want the results to show, and here on this set. Now we click on OK. So basically these are the same set of results which we got here with the manual calculation in the template. Everything is just the same. The only difference is this data analysis tool in Excel will not interpret the results for you. You gotta interpret it yourself based on your objective, either one tail or two tail. But for the template, it's already set up to interpret the results for you. Now this is how you do a two-sample t-test in Excel.